Hi everyone, my name is Nikki and I'm going to be giving a talk on serverless with Swift, which is very exciting. So let's get started. Sorry for my crazy production setup. Obviously we're all working from home and it's dark here and I couldn't get the lighting to be just right, so pre-apologizing for that. Anyways, my name is Nikki. I'm a senior software engineer here at AWS. I work on all things mobile, so that's going to be your mobile SDKs, iOS and Android, and the Amplify libraries that were launched at reInvent in preview and have now gone GA. Yay, that's exciting. I've been obsessed with serverless since Lambda was first released in 2014, and I've been obsessed with Swift since it was released in, I think, 2015. So they've kind of released around similar times, and I've been obsessed with both since their creation. So it's really fitting that they've now come together and joined forces in the Swift Lambda runtime. So I'm really excited to be presenting it to you today. I host the AWS podcast bi-weekly with Simon Alicia, who I'm sure you all know. And I know you're not supposed to pick favorites, but the Australia community is my favorite community. So I'm really excited to be doing this talk with you guys. And then prior to AWS, I ran my own VC-funded startup. Feels like another lifetime ago. That is my Twitter name, and that's also my handle on all social media platforms, so it should be really easy to find me. My GitHub is the same name as well, so please feel free to shout out at me. I answer all my DMs on Twitter, and I'd love to hear from you. Okay, so what are we doing today? Well, we're going to talk about what the new Swift Lambda runtime is and how to use it, and then I'm going to do a demo where I'm going to demonstrate building a Swift Lambda and packaging it and deploying it to AWS, which should be some fun times. Hopefully we don't have any hiccups since it's definitely new. So what is it? It is a Swift, it is a module built as a Swift package. So Swift Package Manager is Swift's package manager, like NPM or pip or any of the other ones. And it is essentially comes in the form of a package and is a runtime to help you build serverless functions in Swift. Pretty self-explanatory. How does it work? So hopefully this isn't the first time you're seeing Swift, but it is. I'll walk you through it. So we have some structs here, and they are implementing a protocol called Codable, which is a built-in protocol in the Swift standard library that allows you to implement different encoders and decoders. So JSON encoder or JSON decoder implements this protocol, and any object that implements it as well can easily be decoded by any of those encoders or decoders. So you can use any data format. Obviously we use JSON most famously, and the Lambda runtime actually imports the JSON encoder and decoder from the foundation framework in Swift. So it's able to really easily decode and encode JSON objects for you, which is really great. So you can see here, you simply create your Lambda by calling lambda.run, and then you pass it a closure, and the closure takes the Lambda context, the input object, which is of input type, and then a callback. And the callback is actually a result type in Swift. If you've never seen a result type in Swift, it is an enumeration with a success type and a failure type. So you can see you're actually calling .success here and passing it the output type. So that's the basics. Now, what about events? So, right, we don't just use Lambda to run some extraneous code. We often receive, Lambda events inside our AWS account, SQS messages or API gateway events or SNS messages or various things inside. And so they did build a module called AWS Lambda Events, which is all those objects pre-created for you that you can just take advantage of in code. I think it's pretty awesome. And so this is an example of receiving an SQS message and sending no response. So we're sending back void. Even API gateway events are supported. I wanted to show this one because they support both the request and the response. You can see how easy it is here to just send back a status code of 200 in your response. So iOS developers everywhere should be super stoked on this because you can now create your iOS apps and your own APIs using Lambda and API Gateway in your favorite language, Swift. So this is really exciting. I mean, obviously I'm super excited, so hope you are too. Okay, so what about performance? So let's jump back 1 second. So we saw the lambda.run with the closure. So what this is actually doing is it's actually running your code on a separate thread from the underlying process that the Lambda is running on, which means that it's non-blocking, and the Lambda is still, the underlying process is still able to interact with the runtime engine, no matter if your code is like blocking or doing something crazy or really slow. There is a slight performance hit from doing this though, because there is context switching between the threads. So if you have a performance sensitive Lambda, you might want to implement the event loop handler, which is also included in the Lambda runtime package. So here in this example, I'm implementing it, I'm creating my own handler, I'm setting the in and out types, and then I'm implementing the handle function, which is, by conforming to that protocol, it's making me implement that function. And then I'm just passing my object handler to lambda.run. And I can basically avoid the performance hit by doing this. Now, by doing this though, I am not running my Lambda, running my code on a separate thread. I'm running it on the same thread. So I need to make sure that nothing I'm doing is actually blocking, because if I'm blocking, you know, I could prevent the library from interacting with the Lambda platform, and that could be really bad for you. So you want to be careful about using this, and only use it if you have performance sensitive workloads, and make sure that you really know what you're doing. Okay, so what's under the hood? So if you just use the lambda.run closure, the example that I showed multiple times in the beginning, you're actually taking advantage of this protocol. As you can see here, it is creating an offload queue, so that is, it's spinning up another thread via dispatch queue to run your code on, and that is not interfering with the underlying thread that it's just using to run the Lambda process. So now event loop handler under the hood, is, has the same handle function that you need to implement that we just showed, and then also allowing you to encode and decode from byte buffers. And then we are, this protocol is inheriting from the byte buffer Lambda handler, which is, again, just implementing the handle function, which allows you to pass the context and the event. So it's like the base, basically, it's the bottom layer. Okay, what about local testing? Yes, they thought of that too. So you can just easily wrap your Lambda function with try lambda.withLocalServer. Interestingly enough, I actually was able to test my Lambda without wrapping this, and I'll show that a little later. But yeah, if you're having trouble testing, I think you can just wrap it with this function. There are a number of environment variables that you can fine-tune your Lambda with. So there's log level. This is the logging level as defined by SwiftLog. SwiftLog is an open source library that Apple wrote that creates an awesome logger in Swift. It's set to info by default, and then there's many others here that you can look into. They all are set by default, so you don't need to deal with them if you're not interested in fine-tuning at all. But you can set various things here pretty easily with the runtime. Okay, so let's get into a demo. Okay, so the first thing we're going to do is we are going to create a new directory. So let's go ahead and do that. Well, there we go. Already written for me. Oh, it already exists. Let's call it something else. Let's do some Swift Lambda runtime demo Australia. Bam. Okay, so we need to create a Swift package, which is by just typing Swift package in it and then an executable. We can do that. Bingo. And then we can just open it in Xcode. So let's go ahead and do that. Okay, so again, if you've never seen a Swift package before, you have this lovely package.swift folder. This is, analogous to your package.json or any of those package managers. They all have a file, a config file, where you import all your dependencies. It's very similar. And then we have sources, and then we have the main.swift, where we're actually going to write our code. First, we need to change our package.swift file to actually take in the runtime. And in the interest of time, I've already written a swift.package folder. I'm just going to copy and paste. Sorry I didn't memorize all that code, but it's there for you now. Let's just change the name to be Australia, so we stay in theme. And just copy and paste that. It's probably a lot faster. Okay, so you can see here we are creating an executable, which is the name of our project. We are creating it for the Mac OS platform. You don't need to worry about this because we will package it for the Amazon Linux runtime or Linux 2 runtime in a little bit. So just to build and run, we're gonna have it work on the Mac OS platform for now. We are adding in the Swift AWS Lambda runtime. The way that you do that in Swift package is you basically just refer to the URL of the GitHub, and then I'm saying up to the next major version. And then I'm just doing the same thing here. I'm referring to the dependency. Okay, so now that I've done that, I can actually use it in code. So I can do import AWS Lambda runtime. Well, it's actually fetching, if you can see, all the packages after I saved. So let's give it a second here. So I bet now this will do code completion for me. Nope. Come on. Okay, we'll give it a sec. All right, so let's create an input that implements Codable. And let's do something like audience name, maybe a string. And then we'll create an output. Message. This is the message. It's going to spit out the message to the audience. Okay, so now we can do lambda.run. And then we have context. We have input, which is of type input. And then we have escaping, results, output, error type. This is our result type. Why is this not working? This is gonna be real fun for me. Oh, I need to name this. Bingo. Callback, success, and now we need to pass our output. So let's create our output with a message, and let's just do something simple because we're in the interest of time here. So let's do string interpolation. Let's do the input dot the audience name, and we'll say hi to the audience. Welcome to my Lambda demo. Okay, really basic, I know, but we're just trying to demonstrate that this is actually going to work for us, which it is. So what we need to do to actually run it is we need to edit the scheme, and we need to add an environment variable, and it is called local lambda server enabled, and we're going to set it to true. And now we can actually run it. Yes, you do have to compile code in Swift, so and it failed. Fun times. Huh. Interesting. Okay. That's fun. I'm pretty sure that was escaping. Lambda.run. That's definitely escaping. Oh, duh. I didn't actually write a closure, you guys. I'm like really struggling today. Okay. So I need to write a closure, an appropriate closure. I'm losing my mind. You'd think I'd be so excited to write Swift for you. It's been a while. Cut me some slack. It's been out of the spotlight for a little bit of a while. What? Oh, I don't want to run it on the iPad. There we go. Okay, where's my debugger window? Okay, so now it's running. Look at that. So we have the local Lambda server started and listening on port 7000. It is receiving events at /invoke. So let's call it and see if it works locally. So let's just do curl. I think this is mostly written for me. What did we name that property? Is it audience name? It is audience name. Look at me. Okay, there's our message. We got it back. Hi, Australia serverless mates. Welcome to my Lambda demo. Okay, cool. So that works. So now what we need to do is we need to actually package it up. The first thing we need to do though is we're actually going to have to create a Docker file. So let's go back to Xcode And let's do that. So Docker file. Okay, so there is an image for us that they already created so that we can use to create our Docker image. And I copied it here because I'm not going to remember the name of it. Bingo. There it is. It is the Swift Nightly Amazon Linux 2 image that is available for you publicly. That's great. Okay, so now we're going to do Docker build. Let's change this. Swift Lambda image. Bingo. We're going to build it. Excellent. We built it. Okay, so now what we can do is we can actually run it to compile. Docker run. And that's not the one, so first of all, we need to call the correct image, which is going to be image. And then we're going to call the Swift package function, which is Swift build product. God, our package name is really long. I really regret that right now. And then we pass it release. Okay. So let's see what happens. Okay, so all I'm doing right here is, we called Docker run, and then --rm just removes the image once it's done running. I'm setting the volume to be the current directory that I'm in right now. The working directory is, again, source. And then I'm using the image that I just created in the step before that I built. And then I'm calling Swift build. Okay. So this is actually creating our image, but then we're going to have to actually package it. The Swift Lambda runtime folks, which was a combination of effort from the AWS Lambda team and the Apple folks, and one community member named Fabian, he's awesome, they wrote a script to help you package it. So we're actually going to go pull that script, which is right here. It's available for you in Swift Server, Swift AWS Lambda runtime. So we're going to go to our project, and we're going to add a new folder called scripts. Whoa. And then we'll create a new file called package.sh. Get rid of this Swift. And we're just going to paste in our bash script. And this is going to actually create the appropriate script for us so that we can zip it up and actually upload it to Lambda. We need to, we're going to need to modify that script to give it permissions, which I'll do in a second once this is done. Should be done relatively soon. There it is. Okay, so let's give it permissions, and then let's call Docker run, except for instead of Swift build, we are actually going to call the script. Wow, if I can type. And then we have to give it the name of the package, which again is insanely long. Oh, I must have typed something wrong. Okay, hold on. What did I do? Swift Lambda runtime demo Australia. That looks correct. Something is wrong. We created the image. Looks like it was successful. This like never runs for me. I don't know why. So let's see if the files were actually created. You should be able to figure that out relatively easy by going into the build folder. I don't see a Lambda folder. Interesting. Well, there's our release files. So this script actually creates like a little Lambda folder. Or at least it did. This is going to be fun. Let's debug this. Okay. I must have like, maybe I copied and pasted the script wrong. It looks fine. See, it actually creates this little Lambda folder under the build folder, which is where all the files go. So even if the script fails at a certain point, which for me last time it failed on zip for some unknown reason, it actually still creates all the correct files to be zipped up, which is the runtime files and your executable. Interesting. I must have done something wrong. Well, let's stop this from running. Swift, did I call that the right image? Swift Lambda image. Yep. Okay. Scripts package.sh. Does that actually exist? Yes. All right. I don't know what that error is. Well, I guess we're going to debug this together. Oh, it's a Docker error. Looks like adding bin bash to the top of the S. Okay, but I have that actually, right? Yeah, I do have that right here. Maybe it's because there's a space and it's actually not at the top. Wouldn't that be funny if that was the problem? Okay, here we go. That is the problem. So it actually did create the files. I'll show you. So we have all these files in here, right? For whatever reason, zip does not seem to work in this script, but it does work in my terminal. So I can actually just go into the build folder and I can go to Lambda and then it creates this folder, right? And I see all these files. Okay, these are all the files that I need to package up. So I'm gonna zip them right here. Bingo. So now there is a zip that was created, as you can see here, and this is what I'm actually gonna upload to Lambda. So I'm gonna go to my Lambda functions, I'm gonna create a new function, I'm gonna call this Swift Lambda Runtime Demo Australia, and then I'm going to choose provide my own bootstrap, and click create function. Wow, Lambda. Okay, that was embarrassing. Pretend like that never happened. Okay, so we're gonna upload a zip. So we just created a zip file. So now we just gotta go find it, right? Which is the Australia one. And then Command Shift dot to show those hidden files. Bingo. There's our zip. Wow, okay, cool. Now we save it. And then we should just be able to run it. So remember, we need to give it an input of audience name. So we'll call this our test event. Get rid of all this stuff. Audience name. And then Australia serverless friends. I'm trying to be Australian, but I'm really not. All right, test. Bingo, succeeded. So we should see our output of our message. Hi, Australia serverless friends, welcome to my Lambda demo. It worked, great. So you can see all the stats here. So let's go back to my presentation and let's talk about how this performs against some of the other languages. Okay, so I did this nice little chart for you where you can run basically the same function and this is how it performs. So it's not terrible, it's not amazing, I'm sure it will improve over time. It is a strongly typed language, it does need to be compiled, so it does perform similarly to your strongly typed languages like .NET and Java. It is still faster than them though, interestingly enough, and yeah, so on cold start, right, it's faster than both, it's right after Node, so you're still going to get faster performance times with Rust and Go, obviously. On warm start though, I thought that was interesting because as you can see, the warm start actually took quite some time. So there's definitely some improvement to go. It is still faster than some of the other runtimes, as you can see. It is an open source project. I highly encourage you to contribute to it if you have a serverless background, if you're passionate about Swift, or any of the above, if you want to just help me out, because I definitely want to use this and I would love those numbers to improve. That is the serverless Lambda runtime with Swift. Thank you so much. There's a link to make contributions to the project if you're interested. Not that I had anything to do with it, but I'm definitely promoting it because it's really cool. And then again, there's my usernames on Twitter and GitHub. I really appreciate your time. Have a great rest of your, let's see, it's evening for me, but in Australia it is the afternoon. So have a great rest of your afternoon and evening. And thank you guys. I'll see you all soon. Bye.